Welcome to the video lecture of DST. In this video lecture, I am going to explain about programming structure of VHDL. So as the name indicates, VHDL means very high speed integrated description language. It is a language which will describe the behavioral structure of a digital circuits. So mainly VHDL HDLs are two parts, two types, VHDL and Verilog HDL. Nowadays we use system Verilog also. So in VHDL, in DSD subject we have only VHDL programming. So VHDL programming structure has two parts. So first one is entity and second one is architecture. So combination of these two is program structure of a VHDL. So entity will give the information about external signals, whereas architecture will give the internal structure of a block diagram. Okay, so entity is declaration of external signals, like if we have any block diagram. So for this block diagram, how many number of outputs? So we can define outputs and input information in entity, whereas internal architecture is nothing but the architecture. So first is entity. So entity declaration specifies the name of the entity being modeled and list the set of interface ports. So ports are signals through which the entity communicates with the other models in its external environment. So totally entity means it is declared about the inputs and outputs, which are called as external signals. So the syntax of an entity starts with a keyword followed by entity name is. So port will give the information about inputs and output. So ports brackets signal names colon mode and signal type. So signal names are nothing but inputs and outputs. Modes are, we have different types of modes and signal type. So next end. So an entity ends with keyword end and entity name. So whatever the name we have given for this entity, the same name we should give here also, right? Entity. So I am repeating again. Syntax of an entity is entity name is port, signal name, mode, signal type. So signal names are user identifiers, mode and signal type are keywords. So next is end entity name. So this is a syntax of an entity. So what are the parts? Now we will check. The following section describe the different elements of entity. So entity name, it is user identifier which will give a name to the entity. So whenever we want to call that entity, we can call with this entity name. So next is signal name. So these are the list of user selected identifier to name external interface signals. So what are the external interface signal means? Inputs and outputs. So we can give input and output names using signal names. So next is mode. So mode mode will give the information about these signals will act as in which mode. So the ports can be declared in 4 modes which specify the signal direction. So ports can have one of the following modes. So input mode, either it may be input mode, output mode, in-output mode and buffer mode. So VHDL allows 4 types of modes: in, out, buffer, whereas Verilog allowed only 3 modes: in, out, So buffer is not allowed in Verilog. So what a signal name defined in mode. So in mode, the value of input port can only be read within the entity model. So if a signal is defined in mode then that signal acts as input mode. That means we can read the data from that signal. So second one is out. So when a signal is defined in out mode, that signal is called as output mode, output signal. So we can write the data in that output data. So third one is in out mode. The value of a bidirectional port can be read and update within the entity model. So here using in output mode, we can read the data and update that in output signal. So fourth one is buffer. The value of a buffer port can be read and update within the entity model. However, it is different from the in-out mode that it cannot have more than one source. So it has only one source. These are the different types of modes which are available in VHDL. So next is, so this is an example for how we can write an entity. So it is an example for half adder. So in half adder we have two inputs A comma B and we have two outputs sum and carry. So this is the example for entity for half adder. So as I discussed earlier, entity starts with the keyword entity followed by entity name. Here this is an identifier, user identifier. We can give any name, and this is nothing but is. So entity name is port give the information about which signal is acts as input and which signal is acts as output. So here in half adder we have two inputs. So A comma B are signal names colon mode. So these two is acts as input mode. So we have to write in mode and signal types. So in architecture we have signal types. So these are the signal types. So which I will explain in the next coming video lecture. So we have different types of signal types. So these are acts as whether it may be bit or bit vector. If we have used only one bit, we have to give bit. More than one bit, we use bit vector. So we can write integer, character, time, real. So these are some of the examples of signal type. Here A comma B, those two are in bit. So we can give signal type as bit. So next two outputs sum and carry. So these two are output mode. So these two are signal types are bit type. So we have to give bit, bracket close, semicolon and end entity name. So whatever the entity name we have given here, same entity name we should write here also. This is one example, right? So this is about entity. So what is an entity means? Entity just give the information about external signals. What are the inputs and outputs to that block? So next part is architecture. So architecture, the internal details of an entity are specified by an architecture body using any of the following three modes. So we can write architecture in three modeling styles. Either it may be data flow style, structural style or behavioral style, or combination of all these three also allowed in architecture style. Is it clear? So architecture means which give internal details of an entity which we have written. So an architecture can be written in three styles: data flow style or structural style or behavioral style, or we can combine all these three also. So this is the syntax of an architecture. Architecture can be starts with the keyword architecture followed by architecture name. Of is a keyword, entity. So whatever entity we have to define here, so we can call using that entity name. So we have different types of declaration parts. So we can declare signals, variables or constants, functions, procedures. We can declare before keyword. So architecture name of entity name is declaration part, begin concurrent statements. So whatever the statement we have written here, those statements are called as concurrent statement and end architecture name. This is the syntax of an architecture. So once again I am repeating, architecture will give the internal details of an entity which we are specified by an architecture body. So this is the syntax of an architecture. Architecture name of entity name is declaration. So we have different types of declaration. So we can declare signals or variables, constants. So begin, concurrent statements, and architecture name. So these are the, for example, so we can write architecture like architecture half adder. So for example, architecture half adder of half adder 1 is, so begin, C gets A and B, and architecture name. So I will write the program in, I can explain the program in the next video lectures. So this is about program structure of an entity. So what a program structure of entity have is, an entity program structure of VHDL has two parts, entity and architecture. Entity will give the information about external signals, whereas architecture will give the information about internal details of that architecture. Thank you for watching this.